today we are starting to look at hydrocarbons in lesson 9. 9.1.1 is define a hydrocarbon. A hydrocarbon has its clue in its name as to what it is. If you can see, it's broken down into two parts. So hydrocarbon, the hydro stands for hydrogen and the carbon obviously stands for carbon. So a hydrocarbon only contains carbon and hydrogen. It's classified as a type of organic compound. Organic compounds are compounds that contain carbon. Common questions include, is this molecule a hydrocarbon? And we would look at the formula. A formula like CH4, you can see it's only got carbon and hydrogen, so it is a hydrocarbon. Whereas if you look over here, as well as carbon and hydrogen, you've also got oxygen. Because of the oxygen, it is not a hydrocarbon because it contains things other than carbon and hydrogen. Next, we're going to look at saturated and unsaturated hydrocarbons. Remember, hydrocarbons contain hydrogen and carbon. In order to see whether or not it is saturated or unsaturated, it helps me to think of the name. Saturated begins with an S, and so does single bonds. A saturated hydrocarbon is a hydrocarbon that contains only single bonds. Now, carbon can have up to 4 bonds. So for it to be saturated, it has to have 4 bonds to different atoms. That would make it saturated. Now, on the other hand, an unsaturated hydrocarbon has to have a double or a triple bond. So it has less than 4 bonds to other atoms. A double bond has 2 bonds, 1, 2, between the carbon atoms. A triple bond has got 3 bonds between carbons, 1, 2, 3. Remember though, a carbon has to have 4 bonds. So we have to make sure that we're counting around the carbon. So we've got 1, 2 bonds in the double bond, but we've also got 3, 4 bonds available to bond with other atoms. A triple bond has got 1, 2, 3 bonds to another carbon atom and has still got a 4th bond free to bond with something else. So if it's got a double or a triple bond, then it is unsaturated. Now we're going to learn the terms for different families. We have an alkane family. Alkanes are when the carbons only have single bonds. These are saturated. Then we're going to look at alkenes. Alkenes is a term for there being at least one double bond between the carbon atoms. And as we've said, if they're not single bonds, then it means that they are unsaturated. Finally, there's the family called alkynes. Alkynes has to have at least one triple bond between carbon atoms, and these are also unsaturated. Now we can work out whether or not molecules are alkanes, alkenes, and alkynes by looking at the formula as well as looking at the picture. So, looking at an alkane, remember we've said an alkane has got carbon to carbon single bonds. They've got the general formula of CnH2n plus 2. So we can work out the formula of any alkane that we'd like. If we've got, for example, 4 carbons, then the N is going to be 4. So to work out how many hydrogens we've got, we're going to do 2 times 4, and then we're going to plus 2. So 8 plus 2, that's going to be 10. So that's how we can work out that the formula when we've got 4 carbons in an alkane is C4H10. We would draw out our structural formula showing the bonds. Each carbon has got 4 single bonds. We have carbon 1, carbon 2, carbon 3, carbon 4. Single bonds between the carbons, making sure that the hydrogens make up the bonds so that every carbon has 4. Then we're looking at alkenes. Alkenes are carbon chains that have to have at least one double bond. This time the general formula is CnH2n. Working out if we've got 4 carbons, we can write C4, then H is 2n, so 2 times 4, it's going to be 8. So that's where we get the 8 hydrogens. Now you might see pictures drawn like this. We have the first carbon. This doesn't show a carbon, but we know that it exists. So that's our second carbon. This is our third carbon. And finally, we've got our 4th carbon. We can see that there is a double bond in the middle. That's why it's an alkene. Finally, we've got our group that are alkynes. Alkynes have a carbon-carbon triple bond, 3 bonds. Because we've got more bonds between the carbons, it means we have less hydrogens again. Choosing 4 carbons, this time C4, we would use our formula to work out the number of H's, 2 times 4, and then we would minus 2. So 8 minus 2 is going to give us our 6 carbons. We can see our 4 carbons in a row, 1, 2, 3, 4. We've got our triple bond here. And if we count around each of our carbons, we can see that there are 4 bonds. So this is how you can identify between alkanes, alkenes, and alkynes.